All right. So, oh, geez, packed house. All right. So it's 6:05, and this is November 6th. And, sorry, yeah, here. So we're on design patterns ostensibly. Before we hit design patterns, we're going to finish polymorphism. These aren't quite in the correct order. So just an update on what's being marked. Your midterm is being marked first. And then after that, your assignment 2 will be marked. We think that probably people are more interested in their midterm mark. And then tutorial 6 is due this weekend. I've also released tutorial 7, which is the other tutorial that goes with assignment 3. And assignment 3 is, of course, due in, 2 weeks, roughly speaking. So yeah, that's where we stand today. Yeah. Possibly tomorrow, but it's, I mean, I don't want to lay blame, but we've had some issues, and maybe legit, who knows, right? But we've had issues with things not being finished marking on time. So I apologize. It's not, yeah, I've been told perhaps tomorrow. That's all I know. Yeah. On Gradescope. Yeah, it's all scanned in, and then there's a rubric. You can see exactly what your mark is, and you can initiate a, it's called I forget, a remarking request or something. Regrade request, yeah, exactly. And then I'll tell the TAs to check that, and then so you write down, oh, I think I should have got a mark here because of blah, 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 and then the TA will respond. And same as before, if you guys can't come to a solution, then just email me and I'll take a look at it. So yeah, I think it's pretty straightforward regrades. It's somewhere on Gradescope. You should be able to see it. But other questions? Okay. So we left off. We had learned about inheritance and polymorphism, and then we had looked at an example of a game. This could be a game, well, no. I mean, it's a terrible game, but it's a game nonetheless. But what it illustrates is how you can set about making a game like this. And I'm a big proponent of don't solve problems that you don't have, right? So don't over-design, solve the problems that are in front of you. And if you do that, however, you might end up in a place where I want to expand my game, but I realize that the yeah, okay. But I realize that the design is not very good for expanding this game. So the game is, just as a reminder, this one here, where I have a hero and an orc, and they jump around a row of characters and try to hit each other. And if they hit each other enough times, then one of them dies and the other one's victorious. And so yeah, I wrote this. The design is not good, so we're going to fix it up. The first thing we're going to fix, we're going to fix a bunch of things, but the first one is this one. This one. So I have a hero and an orc, and I want to add more characters. But one thing I noticed is that I'm already duplicating a lot of code, right? So my hero has these attributes, and so does my orc. They have the exact same attributes, and that seems sort of full. And they have almost all of the same functions. Okay, so if I want to add a new character, I have to copy a lot of code, and that's, not good. So I'm going to do what's called refactoring, and specifically this type of refactoring is I'm going to extract a superclass from these existing classes. And this superclass is going to take all of the code that they have in common and put it up in one class, and then I never have to copy it again. I can just inherit from them. Okay. So specifically, I'm going to take all of the member variables and a bunch of the member functions. And the ones that I know how to implement, there's a bunch of functions that are exactly the same implementation between orc and the hero. So I'm going to implement those in character. But there's a couple functions like update and print that these are going to be slightly different between the hero and the orc, update especially. So these are going to be abstract function or virtual functions in C++, right? So there's going to be an abstract character as an abstract class. And then I'm going to implement update and print in the derived classes of hero and orc, and that should simplify my characters quite a bit, because really the only thing that's different about them is how they move around and well, the types of weapons, but that's not a functional difference, that's a difference in data. Okay, so let's do that. So once again, refactoring is I take an existing game, or sorry, an existing application, and I'm going to redesign it, but I'm not going to change any of the functionality, right? So in the real world, of course, when you refactor, you can sometimes tweak things, but you know, in our imaginary perfect world, we're simply going to refactor and leave the functionality as is. So I want a character class. So yeah, let's add character.h. And then I'm going to steal a bunch of stuff from my hero class, including all of these libraries that I'm importing. Okay, now this, be very careful of, because now I have the same header guards in two different files. And if you don't catch that, that will for sure be a problem later. And then class character. Okay. Okay, so let's make a constructor. Now, if I look at my hero class, in the constructor, I just hard code a bunch of values. So I have an avatar and a health and a position. So in my character class, I'm going to be slightly more formal about initializing these things. So this will be my avatar, health, and position. Okay. And then I'm going to go into hero, and I'm going to steal a bunch of this stuff again. So as we saw in the diagram, all of these functions plus update and print are going to go into my character class. I'll just take these. Okay, and so I'm going to start with the hero, and then we'll do the orc after. These also have to go, but I want to copy them because they're going to be implemented here. So this is going to be now, these are both pure virtual functions. All right. Yep. So that's how we define a pure virtual function. So this is C++ syntax for saying that this does not have an implementation in this class. Yeah, so a virtual function has the virtual keyword. A pure virtual function has the virtual keyword plus equals 0. And that's, you know, sort of what's going on behind the scenes with the compiler is that a function is actually a memory address of that function. So I can pass it as a variable and stuff like that. But if I assign it 0, then the compiler knows that, oh, it doesn't actually exist. So yeah. Other questions? Yeah. Yeah, if I had, so let's take the print, for instance. I'm going to make it a virtual function, but not a pure virtual function. Actually, can I come back to that question? So once I set up the class a little better, it'll be easier to show. So yeah, so I have these. I'm going to take the implementations from my hero class, just to make sure that ideally, as I'm setting this up, I want to get as few errors as possible. So to make sure that the stuff that I'm taking from hero still ends up in hero through inheritance, I'm going to make hero a subclass of character right away. These will all go into my character class. But I'm not going to make them private. I want access in my derived classes, so I'm going to make them protected. So I still have full access in my hero and my orc class to these variables, but outside of the class, no one has access. Okay. So let's make character.cc. And the first thing I want to do is include character.h. And let's start with the print function. So here I say this is pure virtual, which means that I'm not going to implement either of these. But if I, for instance, had update as pure virtual and print as just plain virtual, then I would have to put an implementation here. All right, so I would void character. Okay, and I can leave it empty or whatever. But if I did something like void right, when I try to compile this, this is going to give me an error. So yeah, that's the functionally the difference between the equals 0 and the not equal to 0, even though they're both virtual, is that one is going to have an implementation, and this one, it's not giving me any red squiggles right now, but if I tried to compile character, it would not be happy with me. Or maybe it would be fine. Find the right place. Polymorphism, yeah. All right, well, that's always fun when something unexpected happens. So I will have to, the error might come up when we try to use it. Yeah, I'll come back to that. I'll try it. Well, we're going to try and break it a little bit later. For now, I will, I'll take this out. Oh no. Let's leave it in and see if it gives us an error at some point. Okay. And then the other thing is I want a constructor, avatar int health and int position. I'm getting all kinds of, yeah, because I don't have this. All right, good. Now the compiler's happy with me. Okay, so I have a couple of implementations now. These are empty. And then I'm going to steal these other very simple implementations from the hero class, because these are basically the same whether you're a hero or an orc. They're basically a bunch of getters, or this get hit function, which returns the get hit and the is dead, which are very, very simple. So yeah. Okay, so now I have a character class that's sort of forming up the way that I had originally planned it to be. I'm representing a bunch of stuff that is common between the orc and the hero, and a couple of functions that are common, but that I'm not sure quite implement in this base class because it's too general. Let's see, yeah. So now the hero, I'm going to have to, I hard-coded these values in before, but now I'm going to call the character constructor. I'm going to pass in h, 20, and position 0, and then, okay. All right. So yeah, this is basically what I want my hero to look like. update and print and this specialized collide function that doesn't exist in the orc. Everything that was common is moved up into the character. All the implementations are there. We'll see if these generate any problems. And yeah, so I didn't change anything about my main application. Like I still have references to hero. I'm not getting any complaints from the compiler. Once I compile it, we'll see if that still holds. I do, of course, have to make sure that I include character in the compilation now. And if yes. So I have Copilot on inside my make files, just not outside. Okay, so I've refactored it somewhat. I've made a new class, character. Hero inherits from character. Ideally, it should work exactly the same. So let's take a look. It's just out of date. Okay, so it works exactly the same. The hero is victorious. I refactored functions the same. Slightly better design. We're going to continue with this. Any questions on this specifically? And then I'm going to address that other thing. And the hero has what? When I create the hero? Yeah, I should take in arguments instead of hard coding them. Is that what you mean? In the constructor? You don't know? Yep, that's exactly what I'm doing. So it's slightly different. It's a different syntax from Java. That's all. If I want to what? Oh, when it's created? Yeah, I can put something down here. Yeah. Does this still get called? Is that what you're asking? Yes. The character constructor always gets called first. If I didn't supply this, well, you notice that like the compiler's not happy if I do this because character does not have, so it always gets called first. If I don't supply any arguments, it'll try to call the default constructor, but the character doesn't have a default constructor. So the compiler's saying, look, you have to call this constructor. And really the only way to do it is this. Yeah, that's base class initializer syntax, which is also similar to member initializer syntax. Does that answer your questions or yeah? Okay. All right, other questions? Okay. So I guess I was wrong about this pure virtual function. I thought I tested it, but maybe I'm wrong. Okay, so what it does mean, however, so I have implemented it here. But it does mean I can get away without an implementation. This print function, I can't. So let's try on the other hand. At least this should almost certainly give me an error. Yeah. No space left on device. That's not the error I was looking for. Okay, give me a second. I like VS Code, but it fills up that hard drive so fast with whatever. I mean, this is like a 300 kilobyte program and it caches 5 gigs worth of stuff. Whatever. Could have a gig free. Okay, so yeah, when I take away the undefined reference to vtable for character, yeah. So when I take away the print function, because the print function is not pure virtual, I get an error. If I did make it pure virtual, like the update, then this should then compile. Okay, so you get an error if you don't make it pure virtual and you forget to put the implementation, then you get an error. If you make it pure virtual, apparently you can still put an implementation. It's sort of, I guess I didn't test it as thoroughly as I thought, but yeah. That's why it's always good to try stuff. Okay, so we have a hero, we have a character. Now we're going to do the same with orc. And we're going to have orc inherit from character. So this should be quite a bit easier since character is already set up. Okay, all of this stuff already in the base class. I'm going to put virtual here, which I may have neglected to do in my hero class. This is simply to document that these are pure virtual functions. It doesn't change the implementation at all. And then I'm going to take out, so this, I have to call the and starting position of 14. All right, and that's it. My orc is now updated as well. I should be able to, yeah. And voila, it works just the same as before with an updated design that hopefully is going to pay dividends down the road. Okay. All right, questions? Good. Okay. So the next thing I wanted to do to update my design is, well, I have this base character class that's nice and general. I want to quickly be able to add new characters. So what I'm going to do, if I look at my actual, implementation, I refer to hero and orc a lot, and I want to get rid of that code and replace it with general code that works on characters. So I want a data structure full of character pointers, and then I'm going to replace all of this with for loops over those data structures. So I'm going to put, I have a vector here. Huh, that's interesting. I mean, it'll be, it's just, the language server is just, it's just for VS Code. It talks to VS Code and tells it where to put the red squiggles. So we may have less red squiggles than we should. It'll be fine. We will still get the errors when we compile. Okay, so we have a vector. I want to make a vector of heroes now, or vector of characters. Okay, and I'm going to use pointers. I mean, it's arguable, but I might want to carry references of them somewhere else. Let's say push back. Orc and push back the hero. And now when I add characters, I go here and I push a new character back. But the first thing I want to do is I want to start to replace this with general code. So is over, when is the battle over? Well, before it was over when one of them was dead. More specifically, it's over if there's 1 or 0 people left alive. So that's how we're going to implement it. Since I don't know how many people there are, we're going to keep track of them, run a little for loop. Okay, so I'm going to run a for loop over all the characters and say if, yeah, if they're dead, then update my dead variable. And then, okay, so ch.size is the number of characters. The dead variable is the number of dead characters. So if ch.size minus the number of dead characters is greater than or, no, sorry, less than or equal to 1, then I return true. Alternatively, I can just return that, right? It'll return true if there's 1 or 0 characters left alive, and false otherwise, and that's exactly what we want. Yeah. If what? Well, yeah. But I want to battle to the, I want the, if there's 10 people fighting, let's say, I want to keep going until only 1 is left. Yeah, so it does have a for each, yeah. Yeah, that's a good point. Let's use it and see what some of the pitfalls are. Sure, we'll use it. Yep. Just to know though, if you have trouble with the for each loop, this is always available. Okay. Other questions? Okay. All right, update, simple enough. I want my for loop. So here's the trick with the for each on a, well, sometimes it can be a bit tricky. If I have a vector full of objects, we might have some problems. Full of pointers, though, it's going to be fine. So C out of CH. And I just want to update. So C update. There's other places in the code where I might have to do, I want to keep track of the indexes and do some fancy stuff with them. But yeah, this is fine for now. Okay, so hero and orc move, we did a for each loop. It's nice and general. So this, I should put some comments. This draws the weapons to the board. And this is ugly. I mean, looking at this, could you guess that I'm drawing weapons onto the board? No, right? It's ugly. It's functional, it works, but it's terrible. We're going to fix that a little bit later after we look at some design patterns. We're going to look at a design pattern that fixes this problem. But for now, let's do a for each loop. So I draw the weapons first, and then I draw the characters after that, so that the characters get drawn over top of the weapons. So C. C dot. Yeah, that is really an awful piece of code. It's so hard to tell what's actually happening, but it does actually work. Okay, so that draws the weapons, and then next we're going to do the same thing, but we're going to draw the characters so that they are drawn over top of the weapons. So the character is get avatar. And get position. Okay, now we have a general form of that. Here we check to see who hits who. So in this case, I might be able to do 2 for loops. Let's try this. just for fun. So we're going to use a for each loop. We're going to call, but we have to do a double loop. So we're going to have a nested for each loop. And then we should be able to, yeah, this might work. I'm trying to think if there's anything in a vector that's going to not like that I'm iterating over it twice. So there might be a problem here, but we'll see. So if right, since C1 and C2 are pointers, these are simply memory addresses. If they're the same memory address, they're the same character. And so I don't want the fighter hitting himself. But if they're different, then they're different characters, so I can have each of them hit each other. So if C1.getHit if C1 is hit by C2's swing, then I want to, the get hit automatically deals the damage. I just want to set C1's position to be red in the board. Right, so they hit, when they get hit, they flash red. And yeah, that might actually work okay. We'll see. Certainly the logic is correct, but if I'm using iterators here, it might complain. You know, C++, they try to keep things safe. The last thing, I'm going to leave this as is because it's specialized functionality, and I'm just not going to bother. So the last thing we want to do is print out all the characters. Instead of this line. Okay. Oh yeah, let's do print results. So the battle is over if there is one person left alive or 0 people left alive. So we'll say if C is dead. So if C is not dead, then this is the winner of the battle, and we'll just say C print is victorious. If we exit, and then we'll return. Okay, so if somebody's victorious, we print out they're victorious, and then we exit. If we don't exit, then everyone has died. Okay. So what did I do here is I went through my game loop and I simply took everywhere where I referred to hero and orc explicitly, and I changed that to be this general character type and doing it on a vector. Once again, gonna give you some trouble now. Once again, the functionality should stay exactly the same. I've just updated the design. Okay, so now everything still seems to be working. Hero was created. Yeah, okay, so we added that line. So now I want to see if this actually lets me add a new character. So I want to make a wizard, let's say. So wizard dot. Yeah. Yeah. I don't have to. So let's I mean, this is This might annoy the people at home, but I'm going to draw on the board here. I'll try to explain it. But let's say I'm basically looping over the same thing twice. But let's draw it. So here I have hero, orc, and a wizard. Here I have hero, orc, and a wizard. The first step in my for loop starts here and here, and it says these are the same guys, so they shouldn't hit each other. Then this gets updated to here. It says these two are different, so let's see if this guy hits this guy. And then it goes over here and it says these guys are different, so let's see if this guy hits this guy. And then we go to here. So the hero has tried to hit everyone. They, can't hit themselves, but they can try to hit the orc, they can try to hit the wizard. And then we go to the orc, and now the orc tries to hit everybody. Exactly. Yeah. Yeah. So just by adding a new character to the vector, that character will be able to hit other people. Which, yeah. I mean, it seems rather violent when I describe it, but it's just it's just a game. Okay. Yeah. So add wizard. Other questions? Sorry. Yeah.
I think you would have mentioned that there would be like some sort of but the pitfalls between using like regular for loop and a for each loop.
Right. So there is no pitfall. There's no pitfall when you use pointers. So pointers are nice. They're sort of protected. Yeah. Okay. Let's think about, or let's do a quick example here. Let's say I didn't store pointers. So I made a vector of character objects, and then I added some, let's pretend that I added some characters to it. When I add those characters, those are, of course, copies are made and put in the vector. Whereas in this, when I use a pointer, no copies are made. And now let's say that I want to do this for each loop. Did I already use C? Oh, this is an abstract type. Yeah. Let's make this. Let's try hero then. The same lesson applies. Let's say we had a bunch of heroes. They weren't an abstract type, so we could make instances of them. So now here's my for each loop. So what happens here? So what is a potential, I guess, pitfall of this? So you should think of this as this is still just a parameter, basically. And I'm, in some sense, passing this parameter by value. So when I do this for each loop, every hero from my vector, I'm going to make a copy of them into this local variable. And then I'm going to do some operations on that copy. Let's say that hero takes some damage. Well, that's just it's a temporary copy of a hero. So that hero won't actually take damage. I have to make sure here to pass by reference. So that's the pitfall. And I mean, it's sort of consistent across C++. So it's not really when you're used to C++, this looks normal, but if you're coming from Java or something, this might look normal. That's all. So if you do a loop over objects, you have to make sure to pass by reference. If they're const objects, then of course you have to make this, right? I might have a vector full of const objects, in which case I would make that const as well. Yeah, I just all the same rules as parameters. Other questions? We'll see that again later. Okay, so the whole point of this was that we wanted a wizard. So let's steal some hero code. Actually, let's steal all of the hero code. Okay, so it's a wizard. Wizards don't collide with anybody. And this we will replace with okay, so I have the basics of a wizard. I just have to write my update in print, which should be pretty easy. Wizard.cc. so I'm going to steal this hero.cc. So what my wizard, the abilities the wizard has, they're going to walk slowly like an orc. So orc takes one step to the left or one step to the right. But they're going to have a fireball weapon that they throw, and it's going to crash down randomly somewhere on the board. So that's the, yeah, I have this is dead. If they're dead, return. I want, this will be my fireball position. Okay, so we're gonna fix. Okay, so the fireball does 10 damage, and yeah, sorry, we'll come back to this in a sec. So let's do the swing stuff first. Okay, so my swing, I take a position, it does 10 damage, and it's going to be 5 characters wide. The left-hand position will be at fireball position, and the right-hand position is fireball position +5. That's just the, you know, the position represents the leftmost fireball, and then it's 5 wide, so right is +5. Okay, so we have our fireball now gets thrown by this wizard. The wizard's pretty weak, and we'll put them in location 5 to start. Hopefully they'll be sort of safe there. And this we can get rid of. Okay. The other thing, I'm going to steal some of this. So this is exactly what I want my wizard to do in terms of updating their position, is the orc update. So update the position of the wizard. Okay, so the wizard's fireball. Okay, so now I have an update function specially made for my wizard. I have a complete wizard class. And now I'm ready to try and add it to my battle. So here I'm going to, I mean, there are much better ways to do this part as well, rather than statically allocating and hard coding them. For instance, I would probably want to do something like have a configuration file that lists all the different characters that are in this battle, and I just read from that configuration file in the, what's wrong? So it reads from the configuration file, and then simply in the constructor, and then makes all of those heroes and adds them to the vector. The one thing I forgot to do, which I mentioned, when you're copying, you know, one .h file to the other, sometimes you forget to change your header guards, and then this causes problems that are hard to track down. Okay, so I have a wizard. Did I add him? I simply, all I have to do now is say ch dot pushback the whiz, and that's it. Everything else should just work. So I just make a wizard, I figure out what sort of behavior they want in my wizard class, and then I just add them to my game, and hopefully, well, and then remember to put them in your make file, and then you should be okay. Code in the wizard class. All right, so yeah, the wizard's pretty deadly. So now I have a game that has 3 characters all running around trying to kill each other. The wizard walks back and forth rather slowly, but you can see the fireball is popping up everywhere, and ultimately proves to be too deadly. Yeah, the hero dies here, and then I believe, yeah, I jump out of the update at that point. There's a couple of bugs, perhaps. If the wizard dies, their fireballs will still be on the screen. You probably want to take them off, things like that. But otherwise, yeah. It's still got some really horrible aspects to it, which we're going to fix a little bit later. But I do have a better version of this game than I had before. So, yeah, questions? All right. Okay, so refactoring, once your code reaches a certain complexity, we want to reorganize the structure. We want to improve the design for whatever our problem that we're facing is. In our case, we wanted to add more people to the battle. That what we did there might be different if we had different goals in mind, but okay, so that brings us to design patterns. So we still have some more problems with that code. One, when I call somebody hitting somebody else or somebody updating their position, there's a bunch of ugly getters. You know, I fill parameters by getting these parameters, and that's bad design. We're going to fix that. But first, we're going to take a look at some design patterns, and we're going to, you know, see the one that's ultimately going to fix it. So design patterns, first we're going to talk about the major different categories, and then we're going to zero in on some of the specifics of some of the simpler ones. So in 3004, you're going to see a whole bunch more design patterns and more complicated ones. These are sort of very easy. So facade is in some sense the most vanilla of all design patterns. It's almost polymorphism. The observer, you're probably familiar with observer from things like if you make a GUI, and on my GUI I have a button, and when I press the button, there's a callback function. But maybe there's more than one thing that is interested in that button click. So everything that's interested in that button click registers with that button, and that's sort of the observer pattern. A factory, so this is, I want to create something, but for whatever reason, I don't want to use a constructor, or at least not a public constructor. Or maybe I don't want to call new. One reason might be my game, I have a bunch of game objects, and allocating and deallocating memory is very expensive, right, in terms of CPU cycles, so it's going to slow down my game. To avoid that, maybe I have a pool of objects so when some game object gets destroyed or eliminated or somehow goes out of the game, I take that object, I don't delete it, I put it in the pool, and the next time a new game object comes on the screen, I take that one, I initialize all the values, and then I pass it back, and a factory is a good way to do all that. And then we'll talk about anti-patterns. Yeah, these are basically, maybe a better name for this would be, what you would probably hear a lot is technical debt, right? And what that means is that the same way you saw with the game that, you know, we just worked on, is that I wanted to make a game. I didn't quite know how it was going to turn out. I didn't really know what design patterns to use because I didn't know what problems I was going to face. I mean, you start to get a sense after a while, but let's say that that's the case. When I made that game, I accrued a lot of technical debt, which means that poor design, but it's not the end of the world. I can still improve it. So anti-patterns are in some sense, maybe I wanted to solve the problem right away. I have to get this product out to launch. Maybe I didn't use proper design. That happens all the time. So anti-patterns maybe gives it a bad name. What is a design pattern? It's a way of organizing code to address a common problem, essentially. So there's a bunch of ways to organize our code. We can use inheritance and polymorphism. We can use delegation with composition or composition alone. So when we made our stack a few lectures ago, we did it two ways. We used inheritance, right? That was one way to solve it. Another way was to have a vector inside of our stack class and then forward those calls. So using composition. So that's what those are. We can also say we just have certain operations that we implement and then make use of. So yeah, what happened was there were a bunch of programmers back before this idea of design patterns came up, and they're talking to each other and talking about how they solve these problems, and they realized that they used, even though they were working in different places, when they had similar problems, they came up with similar solutions, right? So they got together, they talked about it, and they realized that there was patterns that kept repeating for these solutions. So they called them design patterns. They wrote a book. That book became quite famous, and yeah. So design patterns, elements of reusable object-oriented software. So this Eric, Gamma, Richard, Ralph, and John, sort of informally known as the Gang of Four. I don't know. I think Gang of Four, I don't remember what it is. It's something historical, right? Some government somewhere, there was a Gang of Four. So these guys earned their name. I don't know the full story, but I do know that this is some political thing. Yeah. And that was the de facto authority. It was sort of the initial attempt to design these patterns. This is not a complete list. There's no such thing as a complete list, right? So as more problems arise, different problems arise with different technologies, we're going to have different design patterns to solve them. We're just going to talk about some of them. So different types, we have creational, structural. So creational is like factory, things like that. Structural is how objects are composed or related. Behavioral is how objects communicate. And architectural is sort of this high-level view of my application. So when I implement a design pattern and I speak about a client class, I'm talking about the class that benefits from that design pattern. Okay, so creational specifies how to create objects. Factory, abstract factory, singleton. Right, so a singleton, let's go back to our game example. I have a battle class that handles the battle, but really I should never have more than one instance of that. Right, there's only ever going to be one instance of the battle class. It controls it. If I have two, I did something wrong. So I can implement a design pattern called a singleton. I can make the constructor private, and then I can make a public function called getBattleClass or something like that. And then if there exists an instance of a battle class, I just return that. And if there isn't one, I make one. And then I can ensure that only one copy of this battle ever exists. Other reasons might be I'm reading from a file, right? Actually, we'll get to that a little bit later. Structural, how objects relate. Facade, bridge, I forget what exactly the bridge is. But the decorator, if you use Java, I don't know if they still do this, but when you read and write to files, you have file reader, file writer, buffered reader, buffered writer, buffered file writer. So this is sort of this idea of a decorator pattern where you, and you know, if you make a buffered reader and you pass in a plain old reader as an argument, so then you're wrapping that reader in a buffered reader, so you're adding functionality. That's this idea of a decorator. Proxy is if I have an object that appears to be on the same machine as me, but when I call a function, it actually goes across the internet, does something, right? So really the thing that I'm calling doesn't exist with me, but it looks like it does and acts like it does. Behavioral, how objects communicate, which objects call which. So observer, again, that Java example, there's other examples we'll talk about. Strategy and visitor. So strategy and visitor are two that we're going to apply to our game. We're going to improve the design with these two design patterns. And then architectural, arguably not design patterns, but I mean, as far as I'm concerned, it's semantics. But yeah, client server, peer-to-peer, model view controller, it's a higher level view of your application and how it's organized. Facade is really just the easiest. I provide a simplified interface to a complicated task. In some sense, this is exactly polymorphism, right? That's the same description. You can think of Python as a facade language. I mean, I'd be very careful with that definition, but it sort of fits. I make a call in Python. These calls are really, really easy. What happens underneath is that they make a bunch of C calls, and these C calls, you know, are way more complex than Python, which is really nice and simple. So the UML diagram for this, I have a client class. The client has a facade class, which is a simple interface. I call some function on the simple interface, and the facade, you know, makes a bunch of complex calls. Another example of that is file input and output, right? When I read and write to a file, it's very, very simple. But if I really dug underneath and saw what was happening, it's very complicated, right? You have device drivers, you have the operating system, and yeah, and then you have the physical disk or whatever you're reading from. So a lot is going on, but I just say open file, read file, write file. These are facades. Observer behavioral design pattern. Yeah, again, yes, I would say facade, again, because facade is such a wide umbrella and it's so general, it's almost a stand-in for anything like where I provide a simplified interface, right? So you could, I mean, is that an example of a facade? Well, it's a question of, you know, how much complexity do you need to be hiding? So I would say yes. That could be thought of as a facade class. Any kind of generalization is a facade. Observer, we have a subject that some other classes are interested in. It maintains a collection of observers. These observers register with the subject. When something happens to the subject that the observer is interested in, it notifies the observers, right? This is also known as the publisher-subscriber pattern, often used with model view controller. Right, so my model updates, and then it signals the view to update, possibly through the controller. But so this would be the UML for the observer pattern. Again, the important part is the subject. I have a subscribe and unsubscribe. So my observer will call subscribe and unsubscribe or pass themselves in as an argument. The subject calls notify when something happens. Notify loops over all of the observers and calls update on them. And then those updates maybe get state back from the subject. This part is not necessary for the observer pattern, but the subscribe, unsubscribe, and update are. And yeah, an example might be if you play Fortnite, like my son, and you can have, you know, your character is alive and they have a living view, or maybe they're dead and you have a dead view. You can float around like a ghost. But as you're playing, if you're playing a game, you're a subscriber to that game. And then when the game model updates, it calls update on your view, and then you render the new view. And yeah. The visitor. All right. So I like the visitor pattern. I'm not very good at explaining it. These slides are sort of not that good, but I'm going to jump around a little bit and try to explain it. And then we'll show a really simple example in that little game we made. So the essence of the visitor pattern is something like this. Let's say I have an element, and I have element A and element B, and I have a visitor, and I have a visitor type A and a visitor type B. So I essentially have 4 different classes, and these classes want to communicate in some way. This is one problem that the visitor problem solves, is that how do I resolve, right? I can, yeah. So I want to call a bunch of functions, fun A and B, but A and B are the general element and visitor classes, and there are subclasses A1, A2, and B1, B2. And essentially, I have 4 different function calls that's possible to make. So how do I resolve this? Well, you can do a table lookup, right? This is an overloaded function, so we can do a table lookup. But the problem is I'm passing in general types, and the compiler maybe doesn't know what those types are, right? Unless I do a runtime inspection, it's not going to know. So one solution is to have 2 sets of functions. I have the accept. This accepts the general type visitor. On this general type, I call visit, right? The compiler now can inspect the underlying type using dynamic binding and call the correct visit function, right? So either visitor A visit or visitor B visit. And then I'm going to pass in an element. And inside that element, I'm going to pass in this element, and then inside this element, I can make other more specific calls. It's a terrible explanation. It's I have to redo these slides, but yeah. So you can sort of get down to, by making these alternating calls, you can get down to the 2 base concrete classes, and then you can figure out exactly what this function is supposed to do, right? So this is a general pattern. What accept and visit as a combination actually set out to do, or the actual purpose is up to you. But this is just a way to resolve these this problem, right? So for example, I have spacecraft and asteroid. They're both space objects. They collide. But I have basically a bunch of different possible functions to call. Yeah. Questions? It's terrible. I got to update that, but I got to think of a good way to explain it. Usually an example is more useful. Yeah.
So is the design pattern just following us, I guess, like the calling, like multiplies of the same function?
Yeah. Let me try again. So in the simplest form, so it solves a bunch of different problems. In the simplest form, if you've ever used Java, and this is the way we're going to do it. So if I have an object that I want to draw on a canvas, then each object knows how to draw itself on the canvas. So I have object that I want to draw. So I call draw, and then I pass in a canvas C. So this is a visitor pattern. So what is the advantage of this? Well, I've passed in this canvas to my object, and now I can access, inside this function, of course, I can access all my private member variables, right? So I can pass them to the canvas and draw myself on the canvas without having to make a bunch of getters, like I did in the game with the wizard, right? So when I drew myself on the board, I had a bunch of getters to get the state and then pass it to the board directly. But instead, I could use this visitor pattern. And now canvas, inside this draw function, I have access to all the private members. I don't need to use getters. I can pass them, I can draw them onto canvas directly, as we'll see. So yeah, that is maybe the visitor pattern in simplest form is this. Right, other questions? Okay. Factory is a creational design pattern used for how an object is created. I talked about objects, pools. That's one possible use. Another might be, maybe I'm making an object, but this object, let's say it's a JPEG. But maybe on different operating systems, it renders slightly differently with a different library and things like that. So if I want to create a JPEG, I have to query the operating system and see what tools are available to render it. And really, my JPEG should just be a JPEG. It should just contain JPEG information. I don't really want to bog it down with a lot of code that has to check all different operating system types. That's not what a JPEG is supposed to do. I want single purpose objects, right? I want simple objects. So I'm going to make a JPEG factory. And this JPEG factory will have all of the necessary information to check about what sort of things are available in this operating system. I can make a correct type of JPEG for this operating system and pass it back to you, right? So I've moved all of that creational logic that doesn't belong in my JPEG class into a JPEG factory. And then now my JPEG is nice lightweight. It just knows JPEG stuff. It doesn't care about operating system calls or things like that. So that's one reason to use a factory. Yeah, so we create the derived object and return a client class. Again, often we have just a general JPEG handle, and then the specific type of JPEG that we pass back, the specific child class, is decided by the factory based on what kind of operating system you're in, for instance. Another way to think about a factory is, I got this from Stack Overflow. I kind of liked it at the time. A factory is a hiring agency, and I want a temporary person to do a job for me, but I don't want to go to the trouble of hiring them. I don't want to go to the trouble of verifying that they have the correct skills or that they're eligible to work in this country or whatever, or that they have the correct licensing. So I have a hiring agency to check all of that, and then they just give me the person to do the job. So that's what a factory is sort of like. The UML, I have a client class. I call on the factory gives me back this product. And behind this product base handle is some concrete subclass that's going to do the job that I want. So another example, I have a game. I'm in a village. I want to get a villager, right? Because the game says, oh, there should be a villager around. But instead of deciding in my game what type of villager there is, I go to the villager factory and say, give me a villager that's appropriate to this town, this location, etc. So maybe it gives me a blacksmith or a guard if I'm near the castle, or a farmer if I'm near the farm. Yeah. And the anti-patterns, again, this is where all programmers start, so not to beat yourself up too much if you end up with some spaghetti code at some point. But yeah, a common problem, the blob. One class contains all functionality. This is, in some sense, the danger of not refactoring as well, right? So not being aware of when the right time to change your code is. All right, design patterns, questions? All right, 10 minutes left, so we're going to talk about a specific design pattern. The visitor is sort of a late addition, so we're going to talk about the strategy design pattern, but we're also going to implement the visitor in our example. So we're going to implement those two design patterns. Let's talk a little bit about the strategy design pattern and the problem it solves. So I have my game, and yeah, that's fine. So yeah. Strategy design pattern, in this case, we're going to use what's called the behavior class. So what is the behavior class? One of the problems with object-oriented programming is that once you make a class hierarchy and you make a class, all of a sudden you are locked into that class and all of its functionality, right? So dynamic binding means that different objects give me different behavior, but now I want different behavior in the same object. So I want to be able to dynamically change the behavior of my object. I don't want to put in a bunch of if statements or things like that. I want this to happen by the compiler dynamic binding. So what I'm going to do is, instead of implementing a behavior on my own, I'm going to have an object in my class, and that object will implement some behavior. And then when that function is called on my client, I simply call my behavior class. And then I can change it out. So, for example, I have a game character class. These game characters can attack. This is a abstract class. And then I have an Inox. I don't know if you guys are played board games at all. I briefly played Gloomhaven, which was a lot of fun, but it's too complicated and one of those things that takes over your life if you're not careful. You guys are gamers? Yeah. Like I've literally, at some point in my life, I've had to this was back when you had games on a CD. I would have to give them away because I'm just like, I need my life back. But yeah, you guys are all managing no 12-step programs. They're fun. They're fun in I mean, I still like them. My kids play them more than I do, but yeah, in moderation, they're great. A great way to relax. Anyway, so I have this Inox character. He's a character from the game Gloomhaven, and there are 3 different types. There's an archer, there's a shaman, and there's a fighter, and they all have this attack function. And I also have a player, and my player can attack, but I want to add some variety in the way my player attacks. In particular, I kind of want to mimic this. I want my player to be able to be an archer, or to pick up a spell and use that, or to pick up a sword and swing it. So I can do this class hierarchy like this. And this is okay, sort of. I mean, I'm duplicating a lot of code between my archer class here and my archer class here, right? Presumably, they're going to be the same behaviors. It doesn't allow a lot of flexibility in terms of if my player puts down his bow and arrow and picks up a sword, well, I really need an entirely new object to implement that in this sort of structure, right? So that is kind of okay. It's a traditional approach, promotes encapsulation, data abstraction, uses polymorphism, not very flexible. We want to change the behavior at runtime. Okay. So we want to encapsulate the behavior inside a behavior class, and then we're going to delegate the behavior to a different object. So we got, what, 7 minutes? So a solution might look like this. So whereas before, my game character, maybe in this case, it's still abstract. But what's not abstract is this attack function. This attack function now exists in my base class. It's a concrete function, and what it does is it calls the attack class on this, and this should really be an attack behavior. So it calls, so I have now an abstract class called attack behavior, and it has an abstract function called attack, and it has a bunch of concrete subclasses, behavior classes that know how to attack in different ways. So the shoot class knows how to shoot a bow and arrow, the cast knows how to cast a spell, and the swing knows how to swing a sword. So what happens now in my game character calls this attack, polymorphism, and dynamic binding means the compiler decides at runtime which of these behaviors it's going to call. So yeah, and that sort of solves that problem. So now my behaviors are separated from my class, and I can swap them in and out at will. Questions? Okay, so the advantages, we can introduce new behaviors without changing existing code. I can pick up a new weapon, I can invent a new weapon, and my entity objects are unchanged. I can share and reuse behaviors, right? So swing and cast, basically any humanoid could use that same behavior, and change them easily at runtime. Slight problem with memory management. But of course, this is the problem we have across the board with C++, and is maybe we don't want to be deleting and reallocating behaviors all the time in the middle of our game. So we probably have a pool. All right, it's 5 minutes. So we're just going to Yeah, okay. I guess we'll just get started a little bit on this. And then, so we have basically the same thing here. You know what? I really could implement it in the same place. Let's stick here. That's this one. Okay. So in my in the game that we just made, we have the wizard, we have the orc, we have the hero, but we want them to be able to, I want my hero to be able to pick up a fireball and throw it. I want the orc to be able to do the same or use a sword. So I want to be able to swap out these behaviors. So we're going to make a couple quick changes here, and then we'll call it a night, just to sort of get the general sense of what we're going to do. So this relies on this update function, but and I wouldn't normally do this, but for the case of just showing this strategy design pattern, I'm going to split update into two different updates. This one's going to be a concrete one, but it's going to be update, what do we call it? Weapon, attack. Yeah, let's call it weapon. And our weapon will need a position, as you'll see. And in here, I'm just going to call, well, what am I going to call? I'm going to make a weapon class. This is going to complain for a little while. I'm going to have a pointer to a weapon class. This is my behavior class. So then in my update weapon, I'm just going to call weapon update. Do I need the position? Yes. Sorry, I don't need position here. I need to pass in the position member variable here. Okay, so this is this strategy design pattern. Now I haven't made a weapon yet, or did I? No, so I haven't made a weapon yet. You know, none of these functions actually exist, and this type doesn't exist. But this is how I'm going to update this character class. And then I'm going to put all of the weapon update functionality that already exists in my update. I'm going to put it in my weapon update. And then I'll be able to swap out weapons at runtime and do different things. The other thing that I'm going to have to do, unfortunately, is change these nice general loops. So in addition to the update, I'm going to need the update weapon. All right. So ideally, I wouldn't have to change the base algorithm. And I could arrange it so that I don't have to, but just to sort of stick to the strategy design pattern that I showed you, I'm just going to add this one little line here. Now what's left is I'm going to make a bunch of weapons. I'm going to create them in the constructors of my client classes, the orc, the wizard, and the hero. And I'm going to move a bunch of logic into that weapon class. And then I'll be able to swap it out at runtime, and the rest of this will stay the same. But don't have time to do that tonight. Any questions? Okay, so next class we'll do that. That's it for tonight. I'll see you guys on Wednesday. Are they going to get the weapons randomly? So that is left to be determined. We could do that. I don't have any current plans to do it, but I am happy to go a little off-roading. It's always fun to do, kind of do things on the fly. So we can try doing that for sure.